Hello everyone, so today I want to go over carbocations and carbanions, but before I begin the video, I just wanted to say thank you for those that are actually following and liking and sharing content, and also commenting, but also to those that are not, please do so because it does take time to create this content. If you are genuinely enjoying the content, please follow for more content. And also you can find it here on TikTok and on YouTube. I'm posting the full videos on YouTube. So go check that out, and it's under different folders like chemistry, organic chemistry, biochemistry, etc. So that way it makes it easier for you guys to have that all condensed into one folder related to that subject. Okay, so going back to this video about carbocations and carbanions, I wanted to make it simpler for you guys because sometimes when chemistry you have so much information to memorize. So just remember, in basic, when you're talking about ions, right, you have cations and anions. Cations are positive, anions are negative. And then you have carbo or carb, so that refers to the carbon. So I hope that helps you guys to remember which one goes with which. Okay, so now let's begin because there's primary, secondary, and tertiary for both. And I want you guys to see why. So in this one, it's only attached to one carbon. So that's why it's a primary carbocation. And the reason that it's a carbocation or a cation specifically is because of the formal charge. So here you're only seeing, you're not seeing the hydrogens that are attached to it. You're just seeing like this blank space here. But technically what happens is you actually have hydrogens that are attached. And in this case specifically, you have two. So I'll show you how that works. So formal charge equals valence electrons minus bonds plus dots. So since this is positive, you're only attached to three things. So because 4 minus 3 is equal to 1. So that's why you have that positive charge there. You don't have a CH3, you have a CH2. And so when you do the math of 4 minus, again, you have the two bonds to those two hydrogens and one bond to another additional carbon. So you only have 3 bonds and you don't have any extra electrons. So 4 minus 3 is equal to positive 1. And now let's go over a secondary. So for secondary, this carbon here is attached to those two carbons. So it is a secondary carbocation. And the same thing with this. I just wanted you guys to see it in a different light, like one in a ring structure, one in a linear form. So that way you'll be more, it'll be easier for you guys to see it in different ways. Okay, and then here, the difference is you're only attached to one hydrogen. You don't have two like you did in the last case. So you have one hydrogen here and you have one hydrogen here. And again, it's 4 minus 3 is going to be positive 1. And then lastly, in the tertiary carbocation, you don't have any hydrogens. There's 0 hydrogens. So, and I'm going to highlight again, this carbon is attached to this carbon, and this carbon. So it's tertiary because it's attached to 3 different carbons. And I'm going to actually put a different color so that way you guys can know which carbon I'm referring to. So the purple carbon is the carbon I'm talking about, and the pink carbons are the ones that they're attached to. Okay, so I wanted you guys to notice one more thing. So, oops, put the wrong pink. So what you guys need to realize also is the following. Notice that this is primary, this is secondary, and this is tertiary. As you increase from primary to secondary, you lose a hydrogen. Then from secondary to tertiary, you lose another hydrogen. I don't know if that's going to help you guys to remember, but I think that that's something that you guys should keep in mind. Because again, in tertiary, you don't have any hydrogens that are attached. In secondary, you only have one. And in primary, you have two. So the other way you can think of it is you need 3 bonds. So that way the formal charge will be positive. So you can think about it, 3 minus 1 would be 2 hydrogens. 3 minus 2 would be 1 hydrogen. 3 minus 3, 0 hydrogens. Just extra information for you guys to process. Now let's go to carbanions. And actually, I forgot to move this up. So for carbanions, you have the opposite effect. So the formal charge is going to be a negative 1, not a positive 1. So what does that mean? We said that the valence electrons of carbon is 4. So 4 minus 5 is negative 1. That means you have to have your bonds and your dots have to add up to 5. So in this case, if you notice, you already have here, you have this carbon bond to this carbon, which makes it, again, it's going to be considered a primary carbanion because it's only bonded to one thing. And it's an anion because, again, it's going to have a formal charge of negative 1. So this, in reality, is only bonded, it's going to be bonded to how many things? It's going to have to be bonded to 5. So again, you're going to have, if you count from this carbon, 2 bonds because it's one bond per hydrogen, so that's 2, and 1 carbon bonded to another carbon, so that's 3, and then the pair of electrons will be 2 dots, so that's going to be 5. Okay, in the next case, you have a carbon here and a carbon here. And so this carbon, you don't have a hydrogen. You don't have any hydrogens at all because you're already triple bonded to another carbon and you have the 2 electrons. So you're already having the formal charge of negative 1. So because remember it's bonds plus dots, so you have 3 bonds, 2 dots, so that's 5. Formal charge of its valence electrons of carbon is 4. 4 minus 5 is negative 1. So, and I'm talking about, again, I'm trying to highlight these so that you guys know. I'm talking about this carbon right here in purple. Okay. Again, this is just for you guys to see it in different ways. Okay, the last 2, let's go over them. So let's talk about the secondary carbanion and the tertiary carbanion. So the secondary, again, it's secondary because it's bonded. This carbon is bonded to 2 different carbons. This carbon is bonded to 2 different carbons. And again, I'll put this carbon I'm talking about in purple. So in this case, you only have 1 hydrogen. So if you notice, in general, it follows the same rule as it did last time, except for this one. This one, it follows a different rule because it has like a triple bond. And again, even in the other one, it would be different if it had a double bond or a triple bond. Just you have to keep that in mind as well whenever you're calculating the formal charge. And lastly, we have the tertiary. No hydrogens whatsoever. And again, I'm talking about this carbon here is bonded to these 3 carbons, so that's why it's tertiary. And again, I'll put it in purple so you guys can have as a reference which one I'm talking about specifically. And the formal charge again is going to be 4 minus 5, so it's negative 1. I hope that's it for this video. If you have any more questions, one last thing I should go over is that for carbocations, the higher the number, the more stable. In other words, a tertiary carbocation is more stable than a secondary carbocation, and a secondary carbocation is more stable than a primary carbocation. So whenever they're asking about stability of carbocations, just remember tertiary is more than secondary, which is more than primary. In another video, I'm going to be talking about allylic carbocations. Actually, yeah. So the allylic carbons are more stable than tertiary carbocations. So keep that in mind. This is not like, but if you're only talking about primary, secondary, tertiary is the most stable. If you're talking about primary, secondary, or tertiary and allylic is the most stable. Okay, now that's it for this video. If you enjoyed all the information that I put on here, please follow me here and on YouTube. If you have any comments or questions, please send me a DM, feel free. And thanks again for watching.